Hello. In this video, we present two retrosyntheses of ethosuximide, an antiepileptic drug. In retrosynthesis A, the imide functional group of the heterocycle is considered as a retron, and the disconnections associated with its preparation generate disubstituted succinic acid as a key intermediate. The following disconnections lead to commercially available raw materials. In retrosynthesis B, the heterocycle is formed from the amino oxygenation of a double bond followed by its breaking to generate raw materials also commercially available. Retrosynthesis A begins with a carbon-nitrogen disconnection that opens the succinimide and forms precursor 2. In 2, the imide group functions as a retron, and another carbon-nitrogen disconnection gives rise to the disubstituted succinic acid 3 and ammonia as raw material. Now, a carbon-carbon connection on carbon 3 of succinic acid generates a derivative of malonic acid 5. Through a functional group transformation, one of the carboxylic acid groups of the malonic acid fragment is converted into a cyano group to generate cyanoacetic acid 6. A second functional group transformation applied to the carboxylic group, located on the quaternary carbon, forms the dicyanocarboxylic acid 7. The remaining carboxylic group is protected as an ethyl ester. One of the cyano groups in 8 is in the beta position relative to the ester carbonyl and the other cyano group. This structural feature suggests a carbon-carbon disconnection based on a Michael addition and forms the unsaturated cyanoacetate 9 and sodium cyanide as raw material. The double bond in 9 can be generated by the elimination of the hydroxyl in 11. The carbon attached to the cyano and ester groups can function as a nucleophile. This structural feature suggests a carbon-carbon disconnection based on an addition to a carbonyl of the ethyl cyanoacetate anion. With this disconnection, ethyl cyanoacetate and 2-butanone are produced as raw materials. In summary, here are shown the disconnections and the reactions on which they are based. Retrosynthesis B begins with the protection of the nitrogen in the succinimide with the benzyloxy group, generating precursor 14. The indicated carbonyl can be formed by the oxidative cleavage of a double bond. With this idea, the lactam with the exocyclic double bond 15 is produced, and the double bond can be prepared by the elimination of the primary alcohol in 16. The neighboring relationship between the hydroxyl and nitrogen suggests for its formation an amino-oxygenation of the double bond in 17, arising from two disconnections, one carbon-nitrogen that opens the heterocycle, and another carbon-oxygen. A carbon-nitrogen disconnection based on an amidation reaction yields carboxylic acid 18 and the O-benzyl hydroxylamine 19 as raw material. The allyl group in 18 is linked to the alpha carbon of the carboxylic acid, suggesting a carbon-carbon disconnection to generate 2-methylbutanoic acid and allyl bromide as raw materials. In summary, here are shown the disconnections and the reactions they are based on. In the following videos, the resulting syntheses will be presented. Thanks for your attention.